of control, and we're going to talk specifically about repetition. So this is different than the flow of control we've been talking about so far. The type of flow of control we've been talking about so far is called flow of control selection. So the idea is you have an if statement or a series of if else statements, or you have a switch statement, and based on the Boolean expression that gets evaluated by that if statement or switch statement, along with a case, you execute a different section of code. So in effect, you're selecting a different section of code. So that's why it's called flow of control selection. So you're using if or switch to select different pieces of code to execute depending on some set of criteria that you've established. So what repetition is, flow of control repetition, is a very different idea. So in this idea of flow of control, what you're doing is you're allowing your code to repeatedly execute itself over and over and over again based on some criteria that you set. So it's very different from selection. Whereas selection, you execute a piece of code just once, and then your program continues to execute without a decision point. With repetition, what happens is you allow a chunk of code to be executed over and over and over again until some criteria that you've set up is satisfied. So let's try like a real simple example to start out with, okay? So here's our goal. In fact, what I'll do is we'll have a definition here, okay? So allow a block of code to be executed repeatedly until some criteria is satisfied. Okay, so that's kind of the definition of what flow control repetition is. All right, so let's create a program. Just do a short program to demonstrate this idea. So I'm going to call this greetings.java. And I'm just going to steal a little bit of code from here so I don't have to type everything over and over again. Experiments.java. There we go. And we'll copy that to greetings. And I'm going to call this greetings. And Bob Dugan, CSC103, and help. This is in-class exercise. So I would say that for those of you that have been watching the videos and you're saying things like, well, I'm watching the videos, but then when I go to do the homework problems, I'm not quite remembering what it is that Bob is asking me to do. I don't remember it from the video, or it looks new to you. So what I would do is, one thing you could do is right now, right along with me right now, bring up Codio and start coding up this exercise just like I'm doing, because that just the act of typing, this is going to help you. Okay, so let me explain what the goal of the program is here. Goal, we're going to ask user for number of greetings. So ask user for the number of greetings, and then we're going to print hello that number of greetings. Okay, so pretty simple idea, but not something that we'd be able to do very easily if we just used the code that we know how to write so far. All right, so, oh, let's do a design. Okay. All right, so the design of the program is going to look something like this. We're going to get number of greetings from user. Then we're going to do something like this. All right, we're going to say if number of greetings is greater than 0, then we'll print hello. And then what we'll do is we're going to subtract 1 from number of greetings, and then I'll just do it this way. I'll have everything kind of indent at the same level. Subtract 1 from number of greetings. Okay, and then go back. All right. I guess we do want to have these indented here. And then done. All right, so this is kind of a design, all right? You can't actually do this in Java, but this is not actual Java code. Lines 9 through whatever, 14 are what we call pseudocode. So they're kind of like English, Java-ish, but it's just something that we can use to kind of get our ideas down for how to design the program, and then we can figure out how to make Java do it after that. So we're going to get the number of greetings from the user. Then we're going to check, is the number of greetings currently greater than 0? If the answer is yes, then we're going to print hello. We're going to subtract 1 from the number of greetings, and then we're going to go back to the if statement again, which will put us back on line 10. And check the number of greetings again. So this will have the effect of creating some repetition, right? We're going to keep checking. Line 10, we'll check the number of greetings again, print hello, subtract 1 from number of greetings, and then go back to if and check it again and again and again. So every time we go to line 10, we're going to check the number of greetings. Every time we hit line 12, we're going to subtract 1 from the number of greetings. So eventually, as we subtract 1 from the number of greetings over and over again, the number of greetings will become 0. Once it is 0, on line 10, if we check to see if the number of greetings is greater than 0, it won't be because it will be equal to 0, and this if won't be true anymore, and then we won't execute any of the code below the if 11 through 13, and we'll end up executing line 14, which is basically done. All right, so let's just try an example just to look at sample run. Okay, so we might see a sample run that looks something like this. Enter, actually, yeah. All right, enter number of greetings. And let's say the user enters 3. Okay, so we're going to print hello. And then at this point, I'm just going to put in parentheses the number of greetings. All right, so we're going to now, once we've printed that hello, we're going to subtract 1 from the number of greetings, all right? And we're going to go back to the if statement on line 10 and see, is the number of greetings still greater than 0? Yeah, the number of greetings is now 2. So we're going to print hello again. All right. And after we print hello, we're going to subtract 1 from the number of greetings. Now the number of greetings is 1. We're going to go back to the if statement on line 10, which says if the number of greetings is greater than 0, well, the number of greetings is currently 1, so the number of greetings is greater than 0. We're going to print out hello again. And now we're going to subtract 1 from number of greetings, so number of greetings is 0. And we're going to go back to the if statement, and it says if number of greetings is greater than 0. Well, the number of greetings is 0, and so the number of greetings will not be greater than 0, so this will not evaluate to true, so we're done executing code inside the if statement. And so we'll jump to 14, done, and the program ends. So that's kind of a sample. I might as well say this, n number of greetings. Okay, all right, cool. So that's kind of pseudocode and a sample run or sample output. I guess that's what I've been calling it in our auto grader stuff. Okay, sample output. All right, so why don't we write the code to make this actually work? All right, so there's a couple things we have to do to make this work. So first of all, we want to write system.out.println, because the first thing we're going to do is ask the user to enter number of greetings. All right. And I'll make that a print so I don't go to the new line. And then we're going to say int greetings equals input dot next int. All right. So to make that input work, we're going to have to say import java.util.scanner. Do that here. And then just before we use the scanner here, we'll say scanner input equals new scanner system.in. All right. And I'm going to write it first as if it's an if statement, and then we're going to modify it so it won't be an if statement anymore. So if greetings, the number of greetings, is greater than 0, then we want to execute the following code. So we're going to say system.out.println hello, and we're also going to output number of greetings hello, and number of greetings I guess I use parentheses here, so number of greetings all right, whoops, let's get that semicolon on the right line here. Okay, and we're going to subtract 1 from the number of greetings. So we're going to say greetings is equal to greetings minus 1. And then we're going to say go to line 31. So line 31 is going to test number of greetings again. Okay, and then maybe when we're done, we'll say system out print line by. Okay, cool. So if we run this right now, let's see what happens. Oops, let's fix that. Looks like we're missing a semicolon there. Build it, whoops, build and run. Let's try running that again. It looks like I just was overly click happy. Enter number of greetings, 5. Okay, hello, number of greetings is 5. Bye. All right, so what happened here? Well, we entered 5, so number of greetings gets set equal to 5. If greetings, which is 5, is greater than 0, got executed. It's greater greetings, which is 5, is greater than 0. So we executed the system out print line. We subtracted 1 from greetings, and then we basically exited the program. Now, the thing I want you to understand here is this is an example of selection, because this if statement is deciding whether the code inside the code block between lines 32 and 36 is going to get executed. But we're talking about repetition here. So how do we get repetition to work? Well, this comment here that says go to line 31 and test number of greetings again, that comment doesn't actually make the repetition happen, but this does. We change this if to a while. So the keyword while means as long as the Boolean expression greetings is greater than 0 is true, kind of like an if, but as long as it's true, we're going to repeatedly execute this code block over and over and over again. All right, so that's the repetition. So just repeat. The while says as long as the code, as long as this Boolean expression here evaluates to true, repeatedly execute the code in this code block. All right, so that's how we get repetition to work. All right, so what's the code in this code block? Well, it prints out hello, then it decrements greetings, then it tests the Boolean expression. Is it still greater than 0? Is the greeting still greater than 0? If it is, then do a system out print line, decrement 1 from greetings, and repeat and repeat and repeat. Okay. Why don't I modify this? Final value for greetings, whoops, value for greetings is all right, so we'll just do that. Little space, get greeting spelled correctly. Okay, so let's try running this. Whoops, misspelled greetings. Let's fix that. Greetings. That's kind of cool, actually. Okay. All right, enter number of greetings, 5. So watch what happens here. So it says, hello, number of greetings is 5. Hello, number of greetings is 4. Hello, number of greetings is 3. Hello, number of greetings is 2. Hello, number of greetings is 1. And then it says the final value for greetings is 0. And then bye. All right, so that's pretty wild. So we now have the ability to repeatedly execute a chunk of code, do it as many times as we want, and that's incredibly powerful. Incredibly powerful. There's a lot of really interesting computations that you can do in programs if you can repeatedly execute chunks of code. In fact, I would say that the ability for you to solve problems by repeating some process, which does some kind of processing, that ability vastly opens up the kinds of problems that you're capable of solving. And we're going to spend the next couple of weeks just messing around with that idea. It's like if we have repetition, what kinds of cool problems can we get into? Okay, so let's try some other examples. All right. Okay. Let's try another. I guess we'll go back to the course notes here. All right, so flow of control, repetition. So let's try another example. So goal, here's what I'd like to be able to do. I'd like to display the numbers from 100 down to 1. All right, so that's our goal. Display the numbers from 100 down to 1. All right, so that's all we have to do. Now, the only thing I'm interested in is just a little bit of code. So you don't have to write all of the code in the program. All I want is the code that makes the repetition work, and maybe if you need a variable or something like that, try that. So the way I want you to do this is I want you to see if just with a pencil and piece of paper, or on your keyboard, whatever, in a little text editor, just write a little bit of code. All right. And so I'm about to write it, but I don't want you to write it until, or I don't want you to play anymore until you've made an attempt. Okay. So using greetings.java and the structure of this while loop, can you figure out a while loop that might be able to display the numbers from 100 down to 1? All right. And I'm going to flip back to here. All right, so go ahead, hit pause. All right, if you've unhit pause, then that means you're ready to check what you did against what I did. So I'm going to say int number, and I'm going to set the number initially equal to 1. And then I'm going to write a while loop. So while number, so I want this to run as long as the number is greater than or equal to less than or equal to 100. Now, if I do that, then I can say system.out.println, and I'll just print line number. And then once I print out the number, so if you think about how this is going to work, I'm displaying the numbers, from 100 down to 1. Oh, well, then I need to do this. 100. And as long as the number is greater than or equal to 1, this should work. Okay, system.println number. Then once I've printed out the number, so the first number I'm going to print out is 100. And then what I want to do is I want to print out the number 99, 98, 97, 96, 95, 94, 93, etc. So I'm going to say number is equal to number minus 1. Okay. So let's think about what this is going to look like for output. So I want to print out or look at the value of number as this executes, right? So number starts as 100. Is number greater than or equal to 1? Yes, it's 100. So we're going to print out 100. Now we're going to make number smaller by 1. Number equals number minus 1. What's the new value for number? Well, it was 100. It's now number minus 1 is now 99. And then once we hit this line 14, we'll jump back up to line 10 because that's the way while loops work. We're at the end of the code block, so we're going to jump right back up to the top of the while loop. And we're going to check, is the number, which is now 99, greater than or equal to 1? Yep, it's 99. So we're going to print out number, which is 99, and now we're going to take the number, which is 99, and set it equal to number minus 1. So it'll be 98. And we're going to repeat that process. And we're going to do that over and over and over and over again until we get to the number being 1. All right, so let's pretend the number was just 2, and now we're going to set it equal to number minus 1. So 2 minus 1 is 1, so now number is 1, and we go up and check, is number, which is 1, greater than or equal to 1? Yes, it is, because it's 1. So system out print line number, and so that will print out the value of 1, and now we're going to say number, which is the value of 1, is equal to number minus 1. Well, number minus 1 is 0. So now number has the value of 0. And now we're going to go back up. After hitting line 14, we're going to jump back to the top of the while loop and say, is the number, which is the value of 0, is it greater than or equal to 1? No, it's not. So we're done with the while loop, and we're done with this chunk of code. All right, so let's try another one. Goal, display numbers from 1 up to 100. So this is slightly different. We're displaying the numbers in a different direction. So the code for this is going to look very similar to the code for this. We're going to start the number at 100, or start the number at 1, sorry, not 100. And we want this loop to run from 1 up to 100. So what do you think we should have here in this Boolean expression? While number, we want the loop to run as long as the number is what? Well, not greater than or equal to 1. If we let it do that, it's going to run forever. We'll talk about infinite loops in a little bit. But what we'd like to be able to do is have this run until the number, as long as the number is less than or equal to 100. Okay? So if the number is less than or equal to 100, then what we'll do is we'll print out the number. So first we'll print out the number 1. What we'd like to do is print out the number 1, then 2, then 3, then 4, then 5. So line 23, which is making numbers smaller, that's not going to work, right? If the number starts out as 1, we'd like the next value number to be 2, then 3, then 4, then 5. So we want to say number is equal to number plus 1. And now we're going to get the pattern that we want. And the pattern's going to look something like this. We're going to have 1, then 2, 1, then 2, then 3, and that's going to continue. And let's just take a look at what happens when the number is 99. Okay, so now the number is 99. So we just did a system out print line of number. The number is 99. Number is equal to number plus 1. That means that number, which is 99, is going to be equal to number plus 1. So number is now 100. And the number is 100, so we're going to jump from line 24 up to line 20 and check out this Boolean expression. Is 100 less than or equal to 100? Yes, it is. So we'll system out print line number, and we will output the value of 100 to the screen. And now number is going to be equal to number plus 1, so number is going to be set to 101. So this, I just want to make a note here, does not okay, this number 101 does not get printed, and here's why. So number has the current value of 101 because it was just 100 and it just got incremented by 1. That's what number equals number plus 1 is going to do. And we're going to, on line 24, jump up to line 20 and then check, is 101 less than or equal to 100? Well, the answer to that is no. 101 is greater than 100, so it's not less than or equal to 100. And so the loop stops executing. Okay. Let's try another one. So here's another goal. let's display even numbers from 1 to 100. All right. So we don't want to display all the numbers from 1 to 100. We want to display 2, 4, 6, 8, 10, etc. We only want to display the even numbers from 1 to 100. So how do we do that? Well, there's a couple ways of attacking this problem. So we'll look at two different ways of attacking it. All right, so the first way is we could take the code that's right here and use that as a template. All right, but instead of starting the number at 1, we could start the number at 2. All right, so number starts at 2 while number is less than or equal to 100, system out print line number. So the first number that'll get printed out is 2. That's good. The next number, though, is going to be number equals number plus 1. That'll be 3. But we don't want to print out the number 3. So what could we do? Well, let's think about the pattern that we have here. We want to go 2, 4, 6, 8, 10. It seems like the numbers are growing up by 2, right? Instead of by 1, they're going up by 2. So maybe if we change this increment here on line 41, number equals number plus 2, we'll get the pattern that we're looking for, all right? So, and it turns out we will. 2, number is 2, then it's 4, whoops, then it's 4, 6, 8, and so on. And let's just look at what happens when it's 98. So we're 98, and we're going to print out 98, and so we'll system out print line 98. Number equals number plus 2, so now number is going to be 100. And we take that 100 and we check in the while loop up here on line 38. Is 100 less than or equal to 100? Yes, it is. So we'll system out print line 100. And then the number, which is 100, will be set equal to the number 100 plus 2. So number is going to be set equal to 102. All right. So now number is 102. So we'll go up and check on line 38. Is number, which is 102, less than or equal to 100? No, it is not less than or equal to 100. So this does not get printed. But that is the value of number when we finish executing this while loop, when we're done executing the while loop. Okay. So we could do this well, I think that's pretty good. So let's we've done 4 examples using a while loop, and that is the first way that we can go about doing repetition in Java. And now what I wanted to do is just sort of look at the while loop. Syntax. So the syntax for a while loop works like this. So you're going to say while, and then you're going to put in some kind of Boolean expression here. And then we have an open curly brace, and we have statement, some line, I would call statement. So statement 0, and then another statement, statement 1. And we're just going to continue doing lines of code until we get to statement n. Okay, so you could have like 1 line of code in here or lots of lines of code, all right? So this thing in inside the brackets that says Boolean expression, you're going to put something in there that evaluates to the true or false. And then these lines of code here, 58 through 60, 61, the stuff that's in here, it's just some number of lines of code. So what's going to happen is, as long as this Boolean expression evaluates to true, then what Java will do is it will execute statement 0 to statement n repeatedly, over and over and over again. When it gets down to statement n, what will happen is it will jump back to the while statement and execute the Boolean expression again. If the Boolean expression still evaluates to true, then these statements will get executed, statement 0 all the way up to statement n. And then the process repeats itself until this Boolean expression evaluates to false. All right, there's another type of loop that is called the DoWhile loop. So it works exactly the same way. It's the same idea as the while loop, but it has just a slightly different syntax. So it looks like this: do, open curly brackets, and we're going to have a bunch of statements like this. And while Boolean So the DoWhile loop syntax is very similar to the while loop syntax. It's just that you put do first, then you start the block of code that you want to have the statements executed repeatedly in, and then you end with this while Boolean expression. Now the only difference between the while loop and the DoWhile loop is that with a while loop, it's possible that the statements inside the block of code will never get executed. Why would they never be executed? Well, if this Boolean expression here up at the top, if this Boolean expression evaluates to false, then the statements in this block of code will never get executed. With a DoWhile loop, you're guaranteed that the statements in the block of code that you want to have repeat, you're guaranteed that those statements will execute once. So statement 0 through statement n will execute once, then the Boolean expression gets evaluated. If it evaluates to true, you're going to go back and execute the statements again. All right, do you see there's like a subtle difference here? So here in the while loop, the Boolean expression acts as a gatekeeper, and it's possible that the statements 0 through n will never get executed if that expression evaluates to false. Here, they will get executed at least once, and if the Boolean expression evaluates to false, only once. If the Boolean expression evaluates to true in the DoWhile loop, they can get executed, those statements 0 through n can get executed more than once. I just want to make sure that you guys understand what I mean by statement. Here when I say statement 0, statement 1, statement n, this could be any bit of Java code, right? So statement 0 could be like a system out print line, it could be an if statement, it could even be another while loop inside of a while loop. So this thing that says statement 0 is really a stand-in for any kind of statement that you might want to write in Java. Okay, so why don't we do an example that uses the DoWhile loop syntax, okay? So what I want to do is I want to create another program, and we're going to call this guessing game with loop.java. So this is that same guessing game that we were using before. Let's see, there's the guessing game Java program. All right, remember this? A little bit earlier, we had guess a number 1 to 100, and it's too high, too low, correct, okay? But I'd like to modify this so that we just keep guessing and guessing and guessing until we end up with the correct number. That's the idea of this program. So, all right, so guessing game with loop. So let's just run the program once to remember what it did, and then we'll modify it so that it works with loop. So guess a number 1 to 100, and I'm going to guess 40. And it says, hey, your number 40 is too low. But I'd like it immediately, if it's too low, to let the user guess again without forcing the user to have to run the program again. That's the idea. So how can we modify this program? Well, the way we can modify this program is we could use a DoWhile loop. So what the DoWhile loop is going to do is say do while, and for right now, I'm just going to say while true. So it's just going to run forever. But I just want to show you it. We'll indent as well here. I like to indent the code because it helps me see the different parts of my program, all right? So take a look at this, right? This is some stuff that gets some input set up for the user. This is the stuff that's inside the do while loop. And if we had any, we'll just put a system.out.println, and this is the code that's outside the do while loop. All right, very friendly program saying goodbye. Okay, so when I run this program, what's going to happen is it's going to repeatedly execute the code inside the do while loop. In fact, when it will execute it as long as the expression inside the while part of the do while evaluates to true. And it's always going to evaluate to true. So this program is actually just going to run forever until basically until I do something to stop it from running, issue a command to stop it from running. So let's try running it. Oh, it's mad. It's saying, hey, you can't do that. This statement line 44 is unreachable. It's unreachable because it's looked at that do while and it sees that it's going to run forever. So it says you're never going to reach line 44. Why should I even have any code there? So I just took line 44 out. We're going to stop this from being a loop that runs forever in a little bit, but I just want to run it just to see what happens to start out with. All right, so guess a number 1 to 100, 40. Too low. All right, guess a number again, 50. Too high, 45. Too high, 41. Too low, 42. Correct. Okay, so at this point, once it's told me that the guess is correct, the program really shouldn't be running anymore, but because we've set it up so that the do while loop always evaluates the Boolean expression to true, it's just going to keep running. 42, come on, I told you it was 42. It's just going to keep running and running and running. Okay. So a way to stop a program that's running forever is to make sure you're clicking in the Codio terminal window and hold the control key down and then the C key. So that's called control C. So this is a way, and you see it has this little caret and a C next to it. That actually will stop the program from executing. Okay, so let's go back and look at our guessing game program. So the problem that we have here is that the program runs over and over again, allowing the user to guess over and over again, which is fantastic. But we really don't want it to run anymore after we've guessed the correct number. So once we've guessed the correct number, we should just stop. So maybe there's a way that we can make that work. So we'd like to have this stop after we've correctly guessed the number. So let's try this. So while, what would, so on line 42, a way that we could rephrase it is we want it to stop running if we've correctly guessed the number. We want it to continue running if we have not correctly guessed the number, okay? So when the guess that we have for the number is guess, and the number is secret. So the relationship between guess and secret is we would like this do while loop to run as long as guess is not equal to secret. So if guess is not equal to secret, we want to go back and run the code in this do while loop. So I hope you're following me here. If guess is not equal to secret, it means that we would like to prompt the user to guess another number. All right, so that changes some stuff here a little bit. So, but let's not change too much other than that right now and see what happens. So I'm going to hit compile and run. And I've got an error. It says cannot find symbol, guess not equal to secret. All right, so let's go back here to our guessing game. So it's saying, hey, I can't find the variable guess, but it was just working, certainly working in here. So the reason why it's failing is because this variable guess needs to be declared not in the inner code block, but in the outer code block right here. So it's declared in the inner code block. So we're going to pull that out here to the outer code block. And the reason for that is that if this do while loop tests variables that are declared in the outer code block at the same level as the do. So guess has to be declared at the same level as the do. It is a little bit of weirdness. Now, last lecture, I talked about scoping rules, and this is an example of a scoping rule. This inner guess is declared inside the inner code block. And so the while part of this do while loop can't access it. So we solve that problem by declaring guess outside the do loop. And now we can use it on line 29. We can assign it equal to input.next, and that's totally legit because usage of a outer code block declared variable it's totally valid for an inner code block to access a variable declared in the outer code block. And now, since this Boolean expression is evaluated using outer code block variables only, we shouldn't get a syntax error. So let's compile and run this. All right, it seems to be happy. So let's try this again. So 40, too low, 50, too high, 41, too low, 42, correct. And then it says goodbye. So let's take a look at what happened here. So go back here. And let's see what happens when we enter the number 40. Let's see what happens when you enter the number 50, okay? Or 40, okay? Let's start with 40. So it says guess a number 1 to 100. The user enters 40. So guess gets set equal to 40. Is guess greater than secret? Nope. Is guess less than secret? Well, secret's 42, so yeah, guess is less than secret. So we print out too low. Then we check to see, is guess not equal to secret? Yeah, guess was 40, secret is 42, so guess is not equal to secret. And so this while evaluates to true, and we go back up to the top of the do while loop and we start executing the code again. So we keep repeating this process over and over again until the user enters the number 42. Guess the number 1 to 100, 42. So now the user types in 42, presses enter. Now guess is set equal to 42. If guess is greater than secret, is 42 greater than secret? Nope. Is 42 less than secret? Nope, because it's equal to secret. Otherwise, 42 is equal to secret, so system out print line, correct. And we can set test now, is guess not equal to secret? Well, guess is actually equal to secret. Guess is 42, secret is 42. So this Boolean expression, guess is not equal to secret, it evaluates to false. All right, because it evaluates to false, we do not go back up to the beginning of the do while loop and execute it again. Instead, we execute the system out print line directly below the do while loop, and we say goodbye, because we're not executing this code inside the code block repeatedly anymore. All right, so what else do we want to mess around with here a little bit? Well, let's go back to our notes. So we've looked at while loops and do while loops. Oh, let's take a look at what would it take to make this a while loop instead of a do while loop? Like, when would you use a while loop versus do while loop? Like couldn't we have done this instead? Taken this while and moved it up here. While guess is not equal to secret, right? Could we have done that? And the answer is we could have done that with a little twist. So the issue is guess has to be set to a value before we can do the while loop test of guess not equal to secret, right? And so what is the value for guess? Well, that maybe we need to go to the user and grab some input from the user to grab that value. So maybe I have to copy and paste this code up here. It's starting to get a little bit messy. And okay, now wait a second. So if it's not equal to secret, then I want to do all this if testing. Okay, well maybe I don't want to put this testing there. Maybe I want to put it down here. Because once I've checked and if it's not correct, I need to guess the number again, but now it's even more complicated because I only want to do this guess a number if I don't have the correct number. So as you can see, the code's getting messier and messier as I try to figure out a way to make the while loop work where a do while loop was very succinct. So another way I could solve this is like this. I could set guess initially to a bogus value, like guess is equal to -1. Now, while guess is not equal to secret, as long as I made sure that the value that I pick for guess is initialized to something that is not secret, then I will drop through this guess not equal to secret, and the program will run the way I'd like it to run. But really, even this can be problematic because sometimes the value that you choose for guess, the initial value you want to pick for guess, might not be something that you can know in advance is invalid. So in this case, picking a guess of -1, I'm saying I think guess is going to be I guess a -1 is an invalid value. So I know that this expression will always evaluate to true if I set guess equal to -1. But sometimes it's hard to pick the right invalid value. And so that can make your code a little messy. So a better strategy in this kind of situation is if you know that you want your code to execute at least once, the code inside the inner block that you would like to repeat, if you want it to execute at least one, use a DoWhile loop. If you're not sure if you want it to execute at least once, if in fact you want to restrict it from executing at all sometimes, then you want to use a while loop. Otherwise, while and DoWhile basically do the same thing. Okay, so let's talk about another problematic thing with loops, or something that's problematic with loops, and that's called the infinite loop. If you've watched some of the Spider-Man movies, you know this quote, and that is, with great power comes great responsibility. So if you have the ability to make your code, a block of code, execute over and over again based on a Boolean expression, what you have to make sure of is that at some point, the Boolean expression evaluates to true. Evaluates to false, so that the block of code doesn't repeat anymore. All right, but sometimes you can forget to do that. So let's take a look at what happens if you forget to have your program Boolean expression evaluate to false. All right, so let's go over here and we'll write just a little bit of code. I'll use experiments.java. Yeah. All right, so in experiments.java, I'm going to say while true. And what I'm going to say is system.out.println with great power comes great responsibility. All right, so that's a lovely quote. And now I'm going to compile and run it and watch what happens. Whoops, nothing happens. Put a semicolon there. I forget a semicolon. I've been doing this for a long time. All right, so what is going on here? Well, what's going on here is because the Boolean expression for the while loop always evaluates to true, the block of code gets printed out basically forever, over and over again, forever. So how do you stop this from running? Well, one thing you can do is hit Control-C. That'll stop it. And the other thing that you can do is you can just close this terminal window. That'll also stop it. And then if you do compile and run, you can start running it again. All right. Now you might be saying, oh, come on, Bob, I'm never going to say while true. But you might do something that is like a computation, like you might do something like this. You might say int number equals 1, and then you say 100, and then you say while number is greater than or equal to equal to 1. And you write some code in here, but you forget to write the little bit of code that changes number. All right? So I run this. And I've got an infinite loop again because I forgot to write something inside the while loop that changes number. Might as well go back there to here. See if we can stop that. All right, and you're like, hey, I'm not going to be that stupid. I'll always remember to. Trying to give it my Control C. It's not really responding. I'm going to close it. Okay, so let's go back here, and you're like, Bob, I'm not going to be that silly. Okay, well, what about this? Number equals number minus let's see, 1 0.5. Let's see. I'm trying to think of kind of a contrived way of number equals number minus 5, 6. All right. So the idea is we're thinking, well, what we're going to do is we're going to decrement a little bit from number, or let's take out 1/4 instead. All right. So we're going to take out like 0.25. All right. So 1/4. So number equals number minus 1/4. So the idea here is we'd like this to run print out about 400 times. All right. So let's run that. I can assure you this is just going to keep running forever. And what we could do is, let's take a look at that again. It's running forever. Maybe instead of saying with great power comes great responsibility, what we can do is we can print out the value of number. All right. It just keeps printing out 100. That's really annoying. But yet over here, I said, hey, I want number to be equal to number minus 1/4. So I'm taking a little bit away from number each time, but it's always printing out number of 100, and it's running forever. It's stuck in an infinite loop. So why is that? Well, the reason is when you take the integer 1 and you divide it by the integer 4, what you're asking is, hey Java, how many times does the whole number 4 divide into the whole number 0? And the answer Java says is 0. It divides in 0 times. Because when an integer is divided by an integer, the result is supposed to be an integer. So we can change that to 1.0 divided by 4.0. And let's run it again and see what happens. Whoops. It's just, I gotta kill that. Try running this again. Pretty clear to me that Control C is not the best. Whoops. What's going on here? Let's try this again. Oh, all right. So let's make it a double, because 1.0 divided by 4.0 is a double. This expression is supposed to be a double. And if this expression is a double, then this value number needs to be a double, unless we do upcasting. Okay, so let's compile one more time. Oh, there we go. All right, so it ran fairly quickly, but you can see the numbers 11.0, 10.7. It actually started at 100, but it just went by really fast. But you can see the numbers being decremented by 0.25 until eventually we end up with a value of 1.0, when you subtract 0.25 from 1.0, you get 0.75, and 0.75 is not greater than or equal to 1, and so the loop stops. So this is an example of that great power with great responsibility. With great power comes great responsibility. You really need to be careful when you're writing loops. It's not hard to write a loop that becomes an infinite loop. And so in Codio, if you have an infinite loop, the best thing to do is when the programs are running, just go to that compile and run tab and just click X to get rid of it. And then go back and look at your program and say, I wonder what caused the loop to run infinitely. When I started my first example, I just said while true, right? And which is an example of the Boolean expression in the while loop always evaluating to true. But then I showed you a not so subtle example of how that can happen, and a little bit of an example of how to get to the bottom of why that's happening. Usually what I do in a while loop, if it's not behaving the way I want it to behave, is I print out the variables that are in the Boolean expression inside the while loop, right? So in this case, I'm just doing a system out print line of number. That shows me how the Boolean expression is being, the computation that's involved in the Boolean expression, the values of the things in that computation. And I can use that as clues to understanding what's going on in the loop. I often find that students that are struggling with while loops gone crazy are just baffled as to why the loop isn't behaving the way they want it to behave. And it's because there's something wrong in their logic. But the question is, how do you reveal that flaw in the logic? And the way you do that is if you take the values of the variables that are in the Boolean expression that's being evaluated by the while loop, and you print those values out in a system out print line statement, you will understand why the while loop's not evaluating the expression the way you want it to evaluate. So you're basically like shining a flashlight on that Boolean expression, trying to get to the bottom of it. All right.